raised to a positive even power, the sign won't change across those. So like x minus 2 squared is why we stayed from plus to plus. Whereas the other one, x minus 1 and x plus 1, those are like odd power factors. It'll change sign from plus to minus as you go across it. Once you understand that, actually once you plug in one test point, you can generate the rest of the pluses and minuses without plugging in more points. There's a shortcut. Anyway, looks like we can solve the inequality. What is it? To get greater than 0, we have minus infinity to minus 2, unioned with minus 2 to minus 1, unioned with 1 to infinity. What if instead of greater than or equal 0, I had less than or equal to 0? What would the answer be in that case? Same expression, but less than or equal to 0. The answer would just be what? Negative 1 to 1 included, right? Let me call this thing Bob. So Bob. Less than or equal to 0 implies solution minus 1 to 1. If we looked at Bob greater than or equal to 0, then the solution would be minus infinity to minus 1 included, unioned with 1 to infinity. So like that minus 2 gets lumped into the solution, and it joins those two intervals into 1 in that case. So I've assigned you like, I don't know, 7 different problems, but they all can be solved using this method. Now some of them have some algebraic like startup cost in mission 2, but we'll talk more about those like next Tuesday, all right? I need to shift gears here and talk a little bit about circles and lines, I think, with the time that we have left. So let me go do that. All right. So I'm guessing you guys have had some previous exposure to graphing lines. Am I right? No? Can't remember? Okay. So lines. Let's give a crash course here. So y equals to mx plus b. This is the so-called slope-intercept form, right? You could also look at y equals to like y1 plus m times x minus x1. This would be point slope. I don't know, there's like 3 or 4 different ones, but really I typically work with either one of these. I find that these are useful to solve problems, and I just kind of go from there. So draw a picture here. So if this is b, this is y equals mx plus b. So m will equal the rise over the run, right? Or you could say it's the change in y over the change in x. To calculate the slope, if you're given 2 points on the line, right? So let me just add 2 points to this line here. Suppose this is point x1, y1, and this point over here is x2, y2. Then this would be equal to y2 minus y1 divided by x2 minus x1. And that's how you calculate the slope, right? You kind of look at like a triangle like this, right? This is the run. This is the rise, so to speak. So, example, if I have y equals to 3x plus 2, I can ask you, okay, what's the slope and what's the y-intercept of this line? What's the slope? Right, slope is 3. And what's the y-intercept? 2, right. Find equation of line through 3, 7, and minus 1, 4. So if I'm faced with a question like this, what I do is I use point slope form. All right, I use the point slope form to solve a problem like this. So I first calculate the slope. So like, 7 minus 4 divided by 3 minus a minus 1, right? So that's 3 over 4. So the slope of the line we're looking for is 3/4. And then you can pick either point that you like. It doesn't really matter. So the answer would be y equals to, I'll use the first one, 7 plus 3/4 x minus 3. There you go. That's the equation of a line that goes through the point 3, 7 and has slope 3/4. What would the point slope form of this line be? How would you find the y equals mx plus b format? What extra step would you do? Distribute, yep. So the gentleman is saying you would do algebra, and you are correct. Let's see here. So what's 7 minus 9/4? 19/4. So there you go. That's the slope-intercept form. Now I can tell you that the y-intercept of this line is 19/4. We'll talk more about these next week, okay? I just wanted to get you started. The other sort of standard example we're looking at in this part of the course is circles. What's the equation of a circle? What's that? Depends on what? Okay, I got you. X squared plus y squared equals to what? How about r squared? Yeah. R. So this is indeed a circle. This is a circle centered at the origin, right? It's the graph of this guy, something like this. Now, we're not content just to have our circle centered at the origin, so we also look at x minus h quantity squared plus y minus k quantity squared equals to r squared. And the solution to this is a circle centered at h comma k with radius r. Now, that one, we might actually have to do some work to get it into that form. Remember that completing the square I talked about in the video? Well, that's going to be needed here to see our way to this kind of form. For example, if I have x squared minus 6x plus y squared minus 8x equals to 0, you might not recognize it right off, but that's a circle. To see that that's a circle, I have to complete the square. So completing the square, that gives me x minus 3 squared minus 9. plus y minus 4 squared minus 16 equals to 0, which gives me x minus 3 squared plus y minus 4 squared equals to 25. So in fact, that equation that I just wrote down is a circle centered at 3, 4 with radius 5. It's not immediately apparent from the original expression, but if we complete the square, we can put that equation into its standard form, which we can recognize as a circle. We'll do more of these next week. I just wanted to get it started. The other thing is, mission 2, I have links to something called Desmos. Desmos is like a free website that's got a basically graphing calculator built into it. So some of the problems in mission 2, I've asked you to use technology for. Make sure you open that electronically and like click here. It will open up Desmos for you, and I've already put in the equations for you. All you got to do is like open it up and look at it. It got the answer to those questions. So I've tried to help you out there. So enjoy. Have a good weekend, guys. Oh, can you hit the stop record for me? It's the red button.